On heating water, bubbles being formed at the bottom of vessel detach and rise. Take the bubbles to be spheres of radius capital R and making a circle contact of radius small r with the bottom of the vessel. If small r is much lesser than capital R and the surface tension of water is T, then value of R, that is this small r, just before the bubbles detach is density of water is to be taken as rho W. In this case, this entire bubble is going to rise up. That is, this part is going to rise up. If it is going to rise up, then it is because of, we can say that, upthrust. But it is prevented from rising by this ring that would be formed at the base of the vessel. This ring will be attached to the vessel, and the force of surface tension exerted by this ring will be, we can say, interaction will be there with the vessel. So if we consider the geometry of situation, then force of surface tension will be acting everywhere at this ring, and it will be acting on the circumferential part. This force of surface tension will be preventing this bubble to be rising up. But when the upthrust becomes sufficiently large enough, then it will balance the force of surface tension in the downward direction, and that will be the cause for the ring to be, for the bubble to rise upward. So this we can show geometrically like this. Let us draw a line joining center to the bubble. Obviously this would be equal to R. Line joining center of the bubble to the center of ring. Let us say that this angle is equal to theta. So obviously this angle will be also equal to theta. Now we can write this fact that bubbles will rise once the force of surface tension will be balanced by the upthrust. So force of surface tension, or force due to surface tension, in downward direction now downward direction surface tension force can be obtained from its component. So this component will become T sin theta. So we can write this T sin theta acting all over circumference, so that would be equal to 2 pi into r, that is radius of ring, must be equal to, let us say, Fst, that is force of surface tension. From geometry we can also write that sin theta is equal to small r by capital R. So T into small r by capital R into 2 pi r must be equal to force due to surface tension. Force due to surface tension must be balancing the upward thrust, and upward thrust will be equal to, we can write down, T into small r by capital R into 2 pi r must be equal to 4 by 3 pi r cube, that is, this entire bubble has radius r cube, mass into density of water, that would be equal to the volume. So volume into density will be equal to mass into gravity, that we will write as G. We will see that this term pi and pi will get cancelled out over here. we will multiply this R, capital R over here, so it will become R raised to 4 over here. This 2 will get cancelled with 4 over here, and making this small r as subject of formula, if we solve it, then it will come out to be r square under root of twice into density of water into gravity by 3 into surface tension force. None of the options are satisfying this condition. This is the methodological or the mathematical solution to the given situation.